one so that you can, always refer in future. All right. Good morning. So now let's start with the set of questions what I gave in the last class exercise, that is on yesterday. So question number 4 was that find the ones and tens digit in 1 factorial plus 2 factorial plus 3 factorial plus up to 49 factorial.
Yeah.
All of you got it?
So I have a doubt in this.
You have a doubt? Oh, sure. Absolutely. We'll discuss on that. So let me first pull the question. That was question number 4, right? All of you got it?
Yeah.
Yeah. So do let me know, where you face it is difficult.
I didn't know how to start it. Like
Okay.
what to do in the question.
Now the point is that when you need to find the ones digit, okay, ones digit means how you find a ones digit of a number with which you should divide to get the ones digit. That first question that you need to ask yourself, okay? Now think about that. If you divide a number by if you divide a number which is ending with 0, can you get a ones digit?
Yeah.
Can you get a ones digit of a number? Suppose you are dividing 1000. Okay. So what is the ones digit there?
0. I mean, yeah.
Yeah, correct. You, isn't it?
Yeah.
So the way to proceed is that after 10, when you find the factorial, if you look into the question, it is 1 factorial, 2 factorial, 3 factorial. In that way, it goes up to 49 factorial. Okay. Now that you can divide as in the entire thing, that you can divide with till 9 factorial. Okay. As you see, this entire number till 49, you can divide it, you can represent it as that 1 factorial plus 2 factorial plus 3 factorial. In that way, it continues till 9 factorial. Got it or not?
Yeah.
Plus, then we are going with 10 factorial plus 11 factorial, plus in that way, plus 49 factorial.
Yeah.
Correct or not? You may have a question, sir, why you did so? Correct.
Yeah.
We know that n factorial is divisible by 100 when n is greater than or equal to 10. Correct or not?
Yeah.
N factorial is divisible by 100 when it is n is greater than or equal to 10, because what is factorial 10? It is 10 into 9 into, and in that way you will proceed, no?
Yes.
Correct. No? It will be definitely divisible by 100.
Yeah.
Correct or not? All of you agree?
Yes, sir.
Yes.
Similarly, it is, if you consider factorial 11, that is also a multiple of 100. Factorial 10 is also a multiple of 100. Correct?
Yes.
So then, that is the reason that we are dividing it into 2 parts. Correct or not?
Yeah.
All of you are absolutely clear what I'm talking about.
Yes, sir.
Yes.
Okay, so the question is that what is the ones digit and tens digit? That is the question, no? So as if the ones digit and tens digit is only makes sense if we only concentrate the problem from 1 factorial till 9 factorial.
Mm-hmm.
Rest is not important because that will be ending with 0, 0.
0, 0. Yeah.
All of you got my point, what I'm talking about.
Yes, sir.
Yeah.
Because whatever you will get it here, that you will get a number. That will get a number. Some number you will get it here. That will find out. And after that, you are adding with something, but ending with 0, 0. Correct or not?
Mm.
So then 1 digit and 10 digit will not contribute from this part,
Yes.
which is coming from here. All of you agree to me?
Yeah. Yeah.
Yes,
So
sir.
now you tell me what is the value of 1 factorial plus 2 factorial plus 3 factorial up to 9 factorial. That you need to compute.
So we need to find the values of.
Yes, you need to find the value. I
So
can
one-
tell you, I can help you if you find the value, because it is so simple, because it is only a little time consuming process.
So
It is 373113. If you find the value, it is 373113. Correct?
Yeah. Yeah. Okay.
Then what will get the 1st digit and 10th digit?
1 and 3. 3 and 1.
3 and 1. Got it?
Okay.
Yes,
That
sir.
1st digit is 3 and 10th digit is 1.
Okay.
Now, related to this question, there are some other questions like, find the remainder when divide the number 1 factorial plus 2 factorial plus up to suppose 100 factorial by 6. A related question. So what you'll do, till factorial 5 will compute, because after 6 factorial all are divisible by 6.
Huh.
Are you getting my point?
Yes. We get it.
So you just similar type of question, it may come that till that time what you'll do, only 1 factorial, 2 factorial, 3 factorial plus 5 factorial you'll go. From
Okay.
6 factorial onwards, all the numbers are divisible by 6, so you should not consider those things, right?
Oh, okay. Yeah.
Clear or not clear?
Yeah.
Yes.
Okay. Question number 5, all of you got it, dear students?
Yes.
Sir, it's 5.
5. Yeah.
Yeah, NS5.
All of you got 5?
Yes.
Fantastic. Question number 6, what is the value of n you got?
I
7.
got 7.
7.
All of you got 7? Do not
Yeah.
hesitate. If someone do not answer, no need to hesitate, because we are learning. So you may have doubt and there is no problem at all.
Yeah.
Now let's come to question number 7.
So I got RS3.
3.
R is yes.
All of you got R equal to 3?
Yeah.
Fantastic. So let me little deep dive into this particular question. This particular question, what you see is that you land up with a quadratic equation in R, right?
Yes.
Yes, sir.
Then what are the values of R you are getting? Sagnik?
3 and 10.
And 10 is not acceptable.
Yeah, because it's greater than n.
5. Fantastic. Very good. All of you got it. Great. Now let's come to question number 8.
4. R
Yeah.
is
Yes, sir. 4.
Wonderful. Okay. Question number 4. Sorry, question number 8. Answer is 4. Question number 9.
5.
5.
5.
Wonderful. Wonderful. Now I think we should move to question number 26, right?
Yes.
Isn't it?
Yeah.
Okay. So question number 26, let me pull the, all of you are done with it. What is the number?
I got 12.
12. Yeah.
You got 12. Okay. What about others?
Yes. So even I got 12.
Disha?
So I got 35.
Yes, I got 35. Not
Yes, even I got 35.
35 is the correct answer. Srijata, what you got?
35.
Correct. 35 is the correct answer. Let me explain you why it is 35. Okay. So we need to little deep dive into the question. We need to, so that is again comes with the fundamental principle of computing. Okay. Let me go to a next page and let me pull the question number 26. That was the question, right? Question number 26. A college offers 7 courses in the morning and 7 in the evening. Find the possible number of choices with the student who wants to study 1 course in the morning and 1 in the evening. Now, I want to give this analogy of this question to one of our previous classes. Remember, Mohor, that we discussed one topic called, the coach. There are, some male players, some female players, and you need to find a mixed double team.
Yeah.
Same thing, right?
Yeah.
I want to take a mixed course, 1 in the morning and 1 in the evening.
Okay. Sir, I thought it would be combination because like selecting.
Yes, sir, even I thought it would be a combination.
You take it combination, no problem at all. You take it as a combination, no problem. It is more than permutation combination. It is actually based on the principle of computing. Let's do in this way. If we take combination, then what is then also we can think of it. Okay. The moment you give, the answer 12, that says that you are taking either a course in the morning or a course in the evening. How many ways you can do it? Suppose these are the morning course. M1, M2, M3, M4, M5, M6, M7, correct? And let's, there is the evening course, 5 evening courses, right? E1, E2, E3, E4, and E5.
Yeah.
What is the question? Find the possible number of choices. Okay.
Yes.
With the student who wants to study 1 course in the morning. Suppose I am a student. I want to take the course M1 in the morning. Now, for this M1 in the morning, I can choose any one of these evening course.
Yeah.
I can take the combination M1 E1, M1 E2, M1 E3, M1 E4, M1 E5.
Yes.
As someone of you say that, oh, I choose is a combination. Okay, no problem. You take E1 M1, E2 M1, E3 M1, E4 M1, E5 M1. Both are same. I'm not incrementing because of that. Correct or not?
Yeah.
For
So
M1, what we are getting? M1 E1. Correct or not?
Yeah.
Then M1 E2, M1 E3, M1 E4, and M1 E5. Correct or not?
Yeah.
Now, if you take that M2, again M2 E1, M2 E2, M2 E3, M2 E4, M2 E5.
Yes.
As someone of you said, sir, I thought it is a combination. You take U1 M1. I'm not taking another pattern for U1 M1. I'm calling only this one. So only for M1, how many we are getting? 5.
5. Oh.
Similarly, for M2, you will get 5. M3, it will get. It is just an analogy to the problem of the mixed double team. Remember?
Yes. So if we write it in the form of formula, then like how can we write?
Formula is not here. Formula is not coming at all.
Oh.
Formula is not coming. It is a possible number of choices.
Sir, I had taken like C12 C1. That's
Why we should take this 12C1? What is the reason behind that? What is the meaning of 12C1? The meaning of 12C1 is that there are 12 items, distinct objects. I am taking only one.
okay.
Does it replicate the problem?
No.
If the question is that there are 5 courses in the morning and 5 in the evening, and you are allowed to choose only one course, in how many ways you can do, then your answer is correct.
Okay, I got it.
Got it?
Yes, sir, I got it.
Now, if you are telling me, no, sir, you give me some kind of a formula to, do this thing, then also you can do it. How you can do it? Tell me how many ways I can choose a course, from the morning out of 7 courses. How many ways? It is 71.
Yeah.
Now, out of all these 7C1, I can choose a course from the evening in the 5C1 ways.
Yeah.
Then that is the answer. That should also give you 35.
Okay.
If you are telling me to know, sir, you apply the formula. Though this particular question is so fundamental, it doesn't need a formula, it needs that how well you apply the concept of principle of multiplication and principle of addition.
Okay, fine, got it.
Correct, no?
Yeah.
Now, let me stay in this problem for another 2 minutes. If the question is that find the possible number of choices so that you can choose any one either in the morning or in the evening,
Then
then
it would
it is 12, and then also you can apply the formula that 7C1 plus 5C1.
yeah.
That also 12. Or you can take 12C1. A problem you can view in multiple ways.
Okay, got it.
Whatever you are doing, there should be a valid justification, isn't it?
Yes.
I
Got it.
trust all of you got it very clearly.
Yes.
Now let's come to the next question, that is question number 27. I hope all of you got it, or if you have any doubt, please do let me know.
Is this 12?
Yeah, I got 12.
Yes, even I got it.
Yes, sir.
Yes. Srijata, you also got Disha, the 12 is the correct one.
Yes, sir.
I'm sorry? Yes, Srijata, you need assistance in this question?
Yes, I got the answer as 12.
Okay, great. So all of you got 12. Then I can skip to the next question. That is question number 20. Question number 28. What is the
I
answer?
got 7.
Yes,
What
even I
about,
got 7.
what about others? Disha, what you got?
So even I got some.
Yeah.
So that, if you look into these two problems, question number 27 and 28, it is so fundamental on the principle of computing, right? Isn't it?
Yeah.
Correct or not?
Yes.
I just praise the question number 27 and 28 just in case you need to have any query, you can ask me. Just a minute. Goodman, you got 27 and 28.
Yes, sir.
Okay. That is question number 27. Good. This is, these are the, ways to actually proceed step-by-step questions. And you will see in another, few days, you will become, you'll be able to solve relatively complex problems. Okay. So this is question number 28. Now let's come to the next question. That is question number 29. Just a minute. So how many? I expect that all of you got question number 29.
I got 120 for the first one
Yes,
and
sir. 120 and 60 for the second.
60.
Yes, sir.
All of you got it?
Yes.
Isha, Srijata?
Yes, sir.
Yes, sir.
Great. So for the first part, you got the answer as 120. And the second part, you got the answer as 60. Appreciate.
Yes.
Appreciate. So I hope then we can make some practice, here, right? Correct or not?
Yeah.
Okay. That was question number 29, which all of you got, correct. Now, let me bring the next question, and it will be, you'll be able to view it but now in the screen. Question number 30 is in front of you. How many 4 letters word can be formed using A, B, C, D, E without repetition? The first part of the question, and second part is that with repetition. If you want to know what is the fundamental difference between without repetition and with repetition, then I can explain you.
So I got a 120 for the first part.
Yes.
Okay.
And the second part I got 5 to the power 4.
5 to the power 4. So fantastic it is.
Yes.
You got this point very correctly. You remember, you make an analogy with what we discussed.
Yes, so the letter.
Letter box. Yes, exactly. Okay. So there are, as if there are 4 letter box instead of letter words. Got it, no? And in first one you can put 4. All of you got it. Disha, Srijata, Gurma,
Yes.
Yes, sir.
Ivansu. Okay, good. Okay. You got the first one. You see, it shows that how well you understand. This gives very good confidence to me as well, that understanding very pretty well. So without repetition, it is 120 words, and with repetition, it is 625 words. And obviously, one statement, what I'm going to make, whenever you construct those words, that word may have meaning, may not have meaning, so that is not under consideration. Okay, with or without meaning, if it is there, then you should not, consider this thing. So now let me proceed to the next question, and we discuss the fundamentals of theorem of behind this question yesterday. So please answer this one and do let me know. It is question number 31.
Okay. So is it like without repetition or like with repetition?
Okay, good question. When the statement is not there, then definitely, you have a choice that the way it is there, you can do. Means for the first one, there is no repetition of the letters, right?
Yeah.
And the second one, there are repetition, but you can consider those repetitions.
We should consider. Oh.
Yeah, absolutely. There is no other choice, because you see, what is the question? How many 7-letter words? Both the words have 7 letters, no?
Yeah.
Correct or not?
Yes.
So the question, doesn't, come into the picture if you go through the, statement properly. Do you agree to me?
Yeah. I got it.
If the words are having many letters than 7, then the question makes sense.
Yeah. Got it.
Yeah. You can just give the answer in the terms of, formula. But later we can compute the value.
So is it 7 factorial for both?
Yes.
5040.
50. Yeah.
Yeah, not for both.
Second one is I got 210.
Fantastic, Sagnik. That is the correct one. Disha, you got it, 210 for the second one?
Yes, sir.
Okay. Yeah, so Sagnik, please concentrate here. For the first one, what you see the bell first. Okay. What we see in this one, all of you, those who have doubt, please have a concentration on this one. If you look into this thing, the word bell first, where all the letters are distinct. Correct or not?
Hmm.
and we are taking all 7. So there are two ways you can see it. One way you can see it, okay, it is 7 factorial, or you can see it as a 7p7. Both are same.
Yeah.
Both are actually same, and that is actually 7 factorial value. If you compute, it will come to 5040.
Hmm.
But the second question is different. Second question is different. What is the second question? Second question says that there are 7 letters in that word, but not all are distinct.
Hmm.
How many A's are there?
4.
1, 2, 3, 4. How many L are there?
1.
How many B are there?
1.
And how
Eh,
many M are there?
1.
1. Now recall the formula that
Yeah.
taking 7 if there are n distinct objects where P1 of one kind, P2 are of another kind, P3 are of another kind, and rest are distinct. What is the way to compute?
Hmm.
The way to compute is that 7 factorial divided by 4 factorial into 1 factorial into 1 factorial into 1 factorial, isn't it?
Yeah.
Recall this formula.
Yes. Yes.
If you recall the formula, what we discussed yesterday,
Yeah.
out of n objects, not all are same. There are repetition in that. That is why it is not n distinct objects, by the way.
Hmm.
Okay, and not all are same. Means that like that. What you see in this question, A is there for 4 times.
Yeah.
Now, if you want to construct different words with or without meaning, how many ways you can construct? So 7 factorial divided by, we need to find all these permutation where it is of same kind,
Okay.
and that value whatever you will get 7 factorial by 4 factorial,
Hmm.
and you can get the value is equal to 210.
Yeah.
And how to compute that? I can also say you how to compute 7 into 6 into 5 into 4 factorial
Hmm.
divided by 4 factorial. Got it?
Yes.
So that is equal to 7 into 6 into 5. That is equal to 210.
Yes.
Anyone has any smallest doubt in this question before we proceed? Clear, right?
Yes, sir.
Yeah.
Great. Can you proceed to the next question?
Yes.
This is a very interesting question, and this will make a lot of your confusion clear. We'll discuss one by one. That question, what I'm going to send you, has 5 parts. Okay, and one by one part we'll discuss and see how it goes. I hope the question is visible to you in front of you.
Yes.
Yeah. Consider the word Hindustan and answer the following questions with justification. So I want to hear justifications from each one of you. How many arrangements can be made by using the letters of the word Hindustan?
So anagram.
I'm sorry?
So what is like anagram?
Anagram is different. Why anagram is coming into the context of this question?
So like how many anagrams?
Okay. Okay. How many of these anagrams, right? The point is that total anagram means is that arrangement of this, all these one taken at a time. That is called anagrams.
Okay.
It is just another, you know, way of saying this thing. How
Okay.
many anagram means how many patterns actually you can say.
Fine.
Total number of anagrams means total number of patterns.
Okay.
you can give the answer in the form of a formula. Later you can compute and you can find the value exactly.
So the first one is it like 9 factorial by 2 factorial?
Fantastic, you fantastic. It is the correct one. It is 9 factorial by 2 factorial. All of you understood why it is 9 factorial by 2 factorial?
Yes, because n is repeated.
Yeah,
N,
n is repeated 2 times and rest of the letters are distinct. Correct, no? All of you got it?
Yes.
Okay, so then the first one we get very well. It is 9 factorial by 2 factorial, and if you compute that value, that will get as 181440. So the first one we got as, I can do it here. It is 9 factorial divided by 2 factorial. And the value you get is at 181440. That you can compute later. It's not a big deal. And you know how to compute. It is 9 factorial, 9 into 8 into 7 into 6 into 5 into 4 into 3.
Yes.
And that is the value. Now let's come to the second one. How many of these arrangements, anagrams, okay, begin and end with a vowel? That is an interesting question. Just spend a couple of minutes of thinking that how many of these anagrams, so total number of anagrams we got it, right? 181440.
Yeah.
Out of these anagrams, how many of these anagrams begin with a vowel and end with a vowel? So for that, you need to first think how many vowels are there, correct or not? How many vowels are there?
And this word
3.
and 3.
There are 3 vowels. So now, if you want to spend a couple of minutes, I think you should spend a couple of minutes. After that, we'll discuss the solution, correct or not? Good morning, you are proceeding, I hope.
Yes, sir.
Great. Same thing with Divansu, Srijata, Pavni,
Yes, sir.
Disha. Go ahead. Good. Okay. Let's what is your thinking? You can share your thought process. Anyone. We can start with Mohor. What is your thought process in this question?
Sir, I don't know what to do after. Like, I know the total number of vowels is 3. After
Okay.
that, like,
Okay. Let's discuss in this thing. Okay. Dear students, think about that. Okay. Let me do this thing. Let me do it here. Okay. Think about that. as you correctly said, there are 3 vowels, right? No.
Mm.
So according to the question, so it's to start with a vowel and end with a vowel,
Mm.
and rest of the things will be with consonants and vowels, right? Whatever it is.
Yeah.
Correct or not?
Yeah.
So how many positions are there in between? So if you look into it, there are 7, total 9 letters are there, no?
Mm.
So
Yeah.
so here there will be a 7 one. 1, 2, 3, 4, 5, 6, 7. Correct or not?
Mm. Yeah.
Tell me this position, that is the vowel position, how many ways you can fill that vowel position? It is the 3 ways because you have 3 vowels, no?
Yes.
Yes.
Now the moment you choose this as a 1 vowel, the other vowel could be here in 2 ways because you are left with 2 vowels.
Yes.
Yeah.
Correct or not?
Yes.
So that means the ways you can choose the vowels, one in the first position and one in the last position, is 3 into 2.
Yes.
Why
Yeah.
3 into 2? Why not 3 plus 2? There is also justification. Because the moment you choose one vowel in the first position, then based on that you can choose the other vowel, 2 vowels in the second position. Correct or not?
Yes. Yes.
Correct or not?
Yeah.
So that is why it is 3 into 2. So
Mm.
first we got 3 into 2. This is the number of ways we can choose the vowels. Now, how many consonant are left here? 7 consonant are left.
Mm.
Yeah.
Correct or not?
Mm.
It is correct or not?
Yes. Yes.
Okay. Now, those 7 consonants, how many ways you can make a pattern?
7 factor.
I'm sorry.
Minus
Actually,
7.
I'm little sorry. It is not 7 consonants. There are 6 consonants, but we have 7 positions, right? Out of these 3 vowels, the moment one is occupied in the first position and one is occupied in the last position, then one vowel is there now which has to be inserted in between, that in this position. Correct or not?
Yes.
That means you have total 7 letters. Correct or not?
Mm.
See how many ways you can make 7 letters by looking into the question, not in generic answer.
7 factorial by 2 factor.
Fantastic.
Yeah.
Because out of these 7 letters, if you see, okay, means if you forget about the the vowel, there are 6 consonants. Correct or not? Out
Yeah.
of the 6 consonant, 2 consonants are alike.
Oh. Wait.
Correct or
Yeah.
not?
And yes. Yes.
Out of these 6 consonants, the 2
Oh.
consonants are alike.
Yes.
Correct or not?
Yeah.
That is N. N is that letter, right? Which is alike 2 times.
Yeah.
We have 7 positions with 2 are alike, so we know it is 7 factorial divided by 2 factorial.
Yes.
That is the answer. Anyone has any smallest doubt here?
Uh,
I can repeat once more. The question is that how many of these anagrams begin and end with a vowel? We see there are 3 vowels. If it starts with if we put one vowel in the first position, then the next position, which is the end position, it can be filled with the 2 vowels. Correct or not? So total number of ways you can do it is a 3 into 2.
mm.
Now, after filling that 2 position, that is the first position, last position, we have 7 letters, 6 consonants and 1 vowel, 7 letters. Out
Yeah.
of these 7 letters, we found 2 are alike.
Yes.
So how many ways we can make the pattern or
7
the
factorial.
anagram or arrangement or synonym? Okay, is that factorial 7 by factorial 2?
Yeah.
See how many things are actually inserted to the single question.
Mm.
And if you find the value of 3 into 2 into 7 factorial by 2 factorial, if you can compute, you will get the value as 15120. So the
Okay.
value what you get is that 15120. Correct?
Yeah.
Now let's concentrate on the next part of the question. In how many of these anagrams none of the vowels come together? None of the vowels come together. How to approach that problem? None of the vowels can come together.
How to start? Like, I don't get it.
Okay, we'll discuss this thing. You can consider, the vowels. What are the vowels? I, U, and A, right?
Yeah. Yeah.
So here the question is that in how many of these arrangements none of the vowels come together? Actually, the question is little different here. There is a small mistake in the question. What I see is that in both question C and D, it is the same. In how many of these arrangements, in how many of these anagrams, the vowels come together?
Vowels come together.
Correct? Yeah, sure. The vowels come together. The next part is correct. Okay, got it?
Okay.
In how many of these anagrams the vowels come together? Let's concentrate on this question. Dear students.
Okay.
Okay, now let's see how many vowels are there. 3. It is I, U, and A. Correct or not?
Yeah.
If we consider these 3 vowels are together, then we can consider them as a bunch. Correct or not? And
Yeah.
after that, what we are left with? After that, we are left with, it is a 6 positions. Correct or not?
Yes.
Are you getting my point, dear students?
Yeah.
Yes, sir.
So the question here is that I reframe the question C. In how many of these anagrams the vowels come together? So as the vowels have to be come together, we can actually make them in a bunch. Okay. So I, U, A, it is there. Then what we are left with? We are left with H. Then we are left with N. Correct or not?
Yeah. Yeah.
Then we left with D. Then S. Then T. Correct or not? And then N. Correct or not? Clear or not clear? So instead of I, U, and A, we can consider them as always they will go together. You can consider them these 3 as a single letter X. Correct or not?
Okay.
So then what we will end up with? We will end up with something like that: X, H, N, D, S, T, N. Correct or not? Where X is actually represented by I, U, A.
Okay.
Now you tell me in how many ways you can make this arrangement possible?
Again, 7 factorial.
7 factorial by
2 factorial.
By 2.
7 factorial by 2 factorial. Now, is it the only answer? Is it the answer 7 factorial by 2 factorial?
No, sir. You have to see how many ways the vowels can be arranged.
Oh, fantastic. So how many ways the vowels can be arranged, among themselves?
3.
Sorry?
3 factorial.
3 factorial, correct. That is into 3 factorial, that becomes the answer. So 7 factorial by 2 factorial into 3 factorial, that is the answer, and that actually comes as 15120 if you compute it, okay?
Okay.
Got it?
Yeah.
Now, the next part of the question, how you can answer the next part of the question, in how many of these arrangements, none of the vowels are together. How to answer this one?
So do you just subtract this
Fantastic.
value from the total?
Yes. There are 2 ways you can do this thing. Yep. You got my point? What Sagnik said, all of you got the point?
Yes, sir.
It is that we already know in how many ways you can construct that one. Correct, no?
Yeah.
That you already found it out.
Mm.
And minus whatever the answer we got in, the point C.
Okay. So like the answer of B minus the answer of C. No.
Not really.
The answer of A, sorry. Like how we have to.
You compute the value. I'll appreciate if you can find the value and do let me know the answer. Think about whether by subtracting you can get the answer or not. Because there are 3 vowels, and that actually leads to the confusion. Apparent, if it is at all. Only by subtraction you cannot get it. What is the question? None of the vowels together. But there are 3 vowels now.
Yeah.
You got my point?
Yeah, there are 3.
You need to look into the problem in different way, because there are some cases where 2 vowels are together, the other vowel is distinct. That should also not be come into this case, right? Sagnik, you got the point?
Yes, sir.
Okay. Subtraction is possible, but the context of the question has to be different. You got my point?
Yes. Yes.
How to do this thing? Now, we can divide the task into 2 parts. In the first part, we arrange the 6 consonant, and that can be done in how many ways?
6 factorial by 2 factorial.
2 factorial ways. Fantastic. Now, let's look into the 3 vowels. Okay. Now, let's look into the problem in this manner. Okay. Now, let's keep the consonants, right? So, how many consonants are there? There are 6 consonants. So, I am keeping the consonant at C, 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 and C. Correct or not? Now, I need to keep the blank spaces between them. Is these are the blank spaces, correct or not?
Yeah.
So in the C places, in how many ways we can keep that, the consonants? It is a factorial 6 by factorial 2. Very well answered. That we get. Factorial, all of you get it, right? Factorial 6 by factorial 2.
Yeah.
Now, there are 3 vowels. And all these 3 vowels can be kept into all these positions. 1, 2, 3, 4, 5, 6, and there is another position. There is total 7 places. Here also 1 place, no?
Yeah.
Yes, sir.
So we have 3 vowels, and those 3 vowels can be kept into these 7 positions.
Hmm.
How many ways you can do it?
7.
7 what?
7 factorial.
No. How?
No.
How
No.
7 factorial? Let me,
No.
without thinking, please do not answer. Or if you answer, then you should justify, right?
No.
There are 7 places are there. You want to keep 3 items. As if like that. Yeah, yeah. Go ahead.
B3.
There are 7 positions. As if you can make that analogy of this problem as there are 7 distinct objects. Out of these 7 distinct objects, you are taking 3 distinct objects.
Be 7P3.
Correct. The moment I say this last statement, you get it 7P3. Now, that is why you remember what I said in the previous class, that it needs good amount of practice. Unless a good amount of practice comes, perfection is difficult. And to get good amount of practice, always you need to go to the online test platform at KonarClasses.com and do many more practice tests after completing your DPPs. So as you correctly said, so how many ways you can do? That is in 7 P3 ways, correct or not? And that could be multiplied, na? Because for each of these 6 factorial by 2 factorial ways, I can choose the vowels in 7 P3 ways.
Yeah.
So the answer is 6 factorial by 2 factorial into 7 factorial 7P3. And if you can compute, I'm sorry, got it or not? And you can compute, you will get the value as 75600. Anyway, if you do not get this value, you can always let me know that there is any mistake in the multiplication. But before I proceed to the next question, all of you please confirm that you understood.
Yes.
You see, in the question D, how many things are actually punched together? That alike, that is the one that 6 factorial by 2 factorial. Then the permutation is there. Then the principle of multiplication is there. You understood all these things are actually clubbed together. But when Sagnik you answered that subtraction, I said yes. Because you may think, if Harry is telling something, how it can be wrong? No. You should also ask me question. You can also, believe my statement with your understanding, with your belief, with your eyes open. Got it? That subtraction could be a very valid answer if we can make this thing, the vowels completely separated. But the problem was that because there are 3 vowels. Got it now?
Yes, got
That is why intentionally this particular word has been chosen, Hindustan. Now let's come to the last part of the question. In how many of these arrangements do the vowels and the consonants occupy the same relative position as in Hindustan? First, you need to understand the question. You need to consume that particular question. Spend some time. Same relative position. What do you mean by same relative position?
Like the same position as it is there.
Exactly. Only thing is that you can replace the vowels by other vowels. You can replace the consonant by other consonants. Correct or not?
Yes.
To me, that is relatively a simple one, but you try it by your own. Anyone has any difficulty to understand the question, forget about the solution. Understanding the question is actually 50% of the solution, reaching towards the solution. Divanshu, did you get the question very clearly? What is meant by the relative position?
No, sir.
Then you should raise. No, I didn't understand. What he says is that in that word Hindustan, okay, so let me explain the problem a little bit here. The question is that how many of these arrangements of the vowels and consonant occupy the same relative position? So let's now look into Hindustan. HINDUSTAN. Now in this first position, what is there? A consonant is there, na?
Yeah.
Suppose C1 consonant. Then there is a vowel V1, correct? Or let me not write C1 V1. Let me write C and V. C, V. Then N. It is again a consonant. Then D. Again it is a consonant. Correct or not? Then U. It is a vowel. Then S is a consonant. T is a consonant. A is a vowel and N is a consonant. So Divansu, what it is saying is that in the position where you see the consonant, no, only keep consonants, correct? Hello Divansu?
Yes, sir.
Yeah. So in how many ways, that is what is called the relative position. Same relative position means in the place of consonant, you can keep only the consonants. And in the place of vowels, you can keep only the vowels. Got it or not?
Yeah.
So one combination could be is that in the first place you can write in, second place you can write I, third place you can write S, fourth place you can write N, fifth place you can write U, seventh seventh place. In that way you can proceed. Got it or not?
So I'm
Yeah.
getting final answers 2160.
Sorry, what is the answer?
2160.
It is the correct answer. But before finding the answer, actually exploring that exact solution, Divansu, did you get my question clear?
Yes, sir. Understood.
You understood, right? So then the problem, how the Mohor, you got that on, correct?
Yes, I
Now,
understood.
as we understood the problem, now let's finding the solution. In how many ways you can make this, 6 consonants arranged among themselves? How many ways? Divansu, you answer.
6 factorial by 2 factorial.
Divansu, I want to hear from you. In how many ways these 6 consonants can be arranged among themselves?
6 factorial, right? By
By 2.
yeah, by 2.
6 factorial by 2 factorial. Okay.
Very 6 factorial by 2.
So why there is a confusion to give that answer? Because we have done similar problem earlier. There are 6 consonants, 2 are alike. Isn't it?
Yeah.
So it is 6 factorial by 2 factorial. These are the ways we can arrange the consonants.
Yeah.
In how many ways you can arrange the vowels?
3 factorial.
3 factorial. Correct. And these, if you can compute, as Saknik said, you will get the answer as 2160. Correct, na, dear students?
Yes.
Then, like the order, it doesn't like.
That doesn't matter. No, nowhere it is mentioned the order. It's same relative position. Na? You will get the same position.
Okay. Okay.
Correct.
Yeah.
If you have any doubt, please ask me.
No, I got it.
Okay, all of you got it very clearly.
Yeah.
Okay, now I would like to give you some assignments for the class on Monday, and please perform some exercise in the. Please do some DPPs.
Okay.
Okay, please do some DPPs. That is important to do DPPs in the online platform. So I'm going to give the assignments here, and In the online platform, you'll get plenty problems, similar type of problems, okay? Plenty of problems are there. Okay. Just a minute. You will get the class notes in another, few minutes after the class, okay?
Okay. Yes.
So before we conclude our class, do you have any, question to me? Any statement?
No.
Okay. All right then. Thank you very much.
So is there class tomorrow or is it?
No, there's no class tomorrow. Tomorrow is Sunday.
Oh,
So we'll have class on Monday. Okay.
okay.
Thank you very much.
Thank you.